Hi, my name is Dr. Patricia Scanlon. I'm delighted to be here at Voice Global with you today, and we need to talk about kids. We need to talk about the accuracy and the bias of voice technology when it comes to kids. So just to give you a quick background, I'm an engineer. I have a PhD in speech recognition, over 20 years experience in speech recognition and machine learning technologies. But I'm also a mother. And back in 2013, when I founded Soapbox Labs, I'd had first-hand experience of how children interact with technology and how voice technology could radically change those interactions. And in particular, when I was watching my daughter interact with educational apps at the time, trying to teach her to read, teach language, teach that really early emergent stage of reading. And I noticed a very significant gap in that none of the technology was able to listen to her pronunciation, her recall, and be able to help her with her reading journey. And it inspired me to look at this area in general, where I really saw how it was underserved for kids of all ages. So Soapbox Labs, we build accurate and safe speech recognition technology for children. We have two core offerings in the play space and the education space. So we license our technology to producers of products and services for children globally. So in the education space, that's to be able to help kids screening, practice, assessment for literacy and language learning, as well as intervention and all forms of speech therapy and helps and tools that can help kids on their reading journey and their language learning journey. And on the play space, we have a separate effort where we look to how we can change how kids interact in a playful way with technology. And we'll talk a little bit more about that later. So first off, why do we need voice technology specifically for children? Well, off-the-shelf speech recognition technology tends not to work very well for kids. It's akin to what speech recognition technology was for adults 10 years ago, which was pretty bad and nobody was really using it at the time. And there's very good reasons for this. For kids, they're physically very different, right? We know that. Their vocal tracts are thinner and shorter. Their vocal folds are smaller. So their actual physical voice resides in a different part of the spectrum. Their speech, their language is different. As children's language develops so much in those early years, from 2 to 4 to 6 to 8 to 10. You can see how their language is maturing. It's becoming more sophisticated. It's beginning to follow the language rules as they get older, when they reach about 10, and they start sounding a little more mature. But their behaviours are so different. Adults tend to be behave very well, actually. There's very little variability in how adults speak when you take dialect and accent out of it. We tend to try and follow the language rules, and we tend to try and realise how we should interact with voice technology to get the best possible result. But kids don't. Kids, they don't follow the language rules, their behaviours, they elongate words, they overpronounce words, they overpunctuate, they shout, they whisper, they sing, and their environments that they're in, that they inhabit, tend to be always noisy. Nobody knows a 4-year-old who likes to go and have quiet time on their own. They tend to be around the adults, they tend to be around other kids, they tend to be with TVs in the background and adults talking and other kids, or in classrooms, playgrounds, or in cars. When they use and want to use voice technology, it's not in a quiet environment, and we have to be really mindful of that. And we also have to be mindful of the channels in which children interact with technology. All different chipset, from cheap old smartphones to more expensive iPads to Chromebooks to laptops to cheap microphones and toys. A voice technology built for kids has to work in all those environments, on all those channels, and to be able to cope with the variability of kids' speech, and kids' speech in terms of their acoustically, how they sound, and the physical differences, but as well as the language and the behaviours. And very much so, we need to be able to protect kids' data. Far beyond what we consider important in any other space in life, our kids are sensitive. It's sensitive when it comes to kids, and we need to be able to respect the privacy of kids' data, and that's critical as well. So when we build for kids, we talk a lot about accuracy and bias. And in particular, we do here at Soapbox Labs. It's been one of our missions when we were to set out in 2013 to bring voice technology for kids. It was to bring accurate and safe technology for kids to use. But a lot of people ask, well, what do you mean when you say it's performance? What do you mean when you say accuracy when it comes to speech recognition? So that's a really, really good question. How do we measure that? So when we talk about accuracy, we're talking about how many words correct did the system get. So we call this word error rate. So often it's, the smaller the number, the more accurate system, or we can talk about it in terms of accuracy. The higher the number, the more accurate and performant the system is. And what happens is, as children get younger, the systems that have been built on adult data, they have been modelling adult language and adult behaviours. They work reasonably well for a mature 10-year-old, 9, 10, 11, 12. They're beginning to sound like little adults. Now, we all know that not all kids are like that. Some kids take a little more development and maturing. But by the whole, when they start getting a little bit older and they start mimicking adults, the systems start to perform well. But what happens when the children are younger? What you see is the performance, the accuracy, the error rates of how many mistakes the system gets starts to dive, right? And there's two different types of error rates we can talk about. When you look at it, is it simply that the system isn't hearing the difference between a child and an adult speech? Or is it in the language and interpreting? So sometimes when you talk to a voice assistant, you may be asking for something way out there that the system has no idea. So it is able to transcribe what you said, but it just can't match what you said to any reasonable response. So you get a canned response going, I can't help you right now. I don't know that answer. Canned responses are quite a thing in speech recognition. I think we're all aware of. But there's another type of problem that exists, is that when people with accents or with dialects that are not served by these speech recognition systems, that you're starting to see something acoustically. It actually can't even transcribe that. And we really see that problem when it comes to kids. So we like to think about it more as, if you're trying to deal with a system to understand a 50-year-old male and a 4-year-old girl, you can start to see how different the child's speech is, their language, behaviours, all these things together. And you're also trying to do it for the 50-year-old man. You're effectively boiling the ocean. It's going to work for some cohorts better than others, and that can be age profiles, it can be in language and dialects, and that's where we start to see bias. So the system not performing for certain demographics as well as it does for others, and that can have very profound effects. Especially when we think about our kids, especially when we think about bringing the system into an educational context, or even in a playful context. No kid wants and gets so frustrated when the system doesn't understand them. And they cop on when they understand when the system's serving them canned responses over and over. They begin to feel like the system isn't listening. That character, the toy, isn't hearing them, and it's a frustration. And the gimmick and the novelty is over and they push it aside. In education, these problems can be quite dramatic. They can be quite negative. If you think about it, so if we talk about false positives and false negatives. So let's say a system listens, and a false positive means that it will tell a kid they are right when they're wrong. Okay, that's not very educational, especially if it happens repeatedly. If you tell a kid they are wrong when they are right, that's damaging, and damages the confidence of the child. Over time you can imagine teachers not wanting to use this, kids getting frustrated, pushing it aside. But often systems that are trying to boil the ocean will say, right, we'll just drop the bar here. We'll just drop the bar and pass everything because we don't want to have any false negatives, which are quite damaging. But as a result, you're producing a lot more false positives. And what we got to really ensure is that we're not creating too many false positives or too many false negatives for different cohorts within the classroom. Because you can imagine a child sitting there seeing it work for their peers and not for them. You're probably more than likely going to be contributing to some systemic biases that are already in the system and inequalities. So it's really, really important when we bring these technologies into the classroom that we do it carefully, and we do it with systems that have been tested and have been validated in terms of accuracy and biases for children in particular. So there was a very famous, well-known, in our circles anyway, a paper in the last year that's been released that actually showed on average systemic biases for adults across all speech recognition systems, all well-known household brand name speech recognition systems, that had demonstrated on average twice as many errors for Black Americans than it did for white Americans. And that, you can imagine, that is devastating for the industry to realise. This paper did an excellent job on being able to uncover a lot of the problems within the acoustic models, because when two people spoke exactly the same vernacular, the system understood one more than the other. So you can see that is a very core problem that started on how these systems, their data was seeded. Really, really important research. And to take that and to realise that's important, it's even more important when we talk about our children. So how do we mitigate bias? Well, at Soapbox Labs, what we've done is being able to look at the data we acquire. We acquire data and we build our systems with data from kids of all accents and social economic backgrounds. And our system has been independently validated by researchers to show that there was no bias in scoring between our system for Black and white students, for white and Latina students, and for high versus low poverty backgrounds. And that was super important for us as a company to bring this technology to market. And we are continually trying to assess and really get into the rigor of the system about to ensure that we're not having issues in different environments, to make sure we're not having issues whether a kid's wearing a headset mic or they're not wearing a headset mic. Can it work in the classroom? Can it work in all these environments? Can it work for all these different children? It's so important to bring technology to the market that is able to ensure that. So our engine, just to give you a little flavour of the types of features the system does, we have on the left-hand side, we're looking at the play side. So this is more, can sometimes be edutainment and brought into the education side as well. So we're talking about voice activity detection, being able to tell and wake up the system when we hear voice and not just random noise in the background, but also to be able to develop custom wake words for a system so the kid can call the system in order to, when they intend to engage with it. We can do voice search, which can really be useful to cut down the clutter on the screen when it comes to menu systems and children trying to navigate to get to what they want. And also when you have screenless systems as well, you want to be able to help the child play that game, engage with that activity through using voice. We can do just transcription and dialogue to be able to have that playful or educational even dialogue between the child and a character, and be able to control a game or an experience. On the education side, that same engine that we've built that has high accuracy and lack of bias for children is around being able to do fluency assessments, reading practice, screening assessments, multiple choice questions, practice, keyword spotting, comprehension, and begin to see how this one engine is serving two individual, very separate verticals in this space. And just to give you a little bit more flavour on the education side, this is something that's really been interesting in the last 18 months around what happened with COVID. We saw a huge surge of interest in our technology to be able to help with children in their practice and their assessment for fluency, and to be able to ensure what levels they were at when they returned to school, to be able to try and catch kids who need intervention, to be able to help the teachers, give tools to the teachers by being able to listen to a child as they read a passage, being able to identify repetitions, insertions, substitutions, deletions, and be able to give the teachers very quickly an assessment on where each child was. And that's just one example of a whole host of technologies that we're bringing to the market and have brought to the market to be able to advance in the education space and create a whole new category of data for educators, for ed tech companies, for teachers, and for students themselves to get that feedback from the system. So some things you need to be mindful when you are integrating voice technology for children. How does it perform? What's the accuracy like? What's the accuracy like when the child behaves well and behaves as expected? And what happens when they don't? What does the system return to you that's useful when they're not complying as much and they're not reading what they're supposed to, or they're not responding as they should? You need to test the rigor of the system. You need to test when in clean environments, you need to test when there's noisy environments, you need to test, a couple of different devices that you expect the children, your customers, your end users will use it in. And you need to look at the entire age group which you expect to use this system. So while a system may perform very well for a 10-year-old, but you do in the future plan to use for 5-year-olds and take them on that full reading journey, does the system work equally well for all those kids? Are you planning on using it in a New York City school or in LA, where you will not just find one type of accent and you will not just find one type of dialect? Does it perform well when you are exposing the system to all different accents and dialects? That's really important. So what you want to do is make sure that you have accounting for your false positives, for your false negatives, for your error rates, and how your system will respond, and then test it in the field. So it's really important to keep these things in mind, because when we're bringing technology for a play experience, whether that's the child interacting with a character or controlling a game, the voice technology reflects on your brand and how it responds. These days, the expectation is that systems should work as well for kids as they do for adults. What isn't expected in the general public is that kids should continue to have a subpar experience when it comes to compared to adults. So Soapbox Labs is on a mission to radically change how children interact with technology, and to be able to do that and unlock so many new use cases and playful experiences and educational experiences globally. So thank you for listening. Please do get in touch.